Next Frontier, Hypersonic Bomber Initiative announced with ambitious 2025 deployment target. Date, February 14, 2025. Overview. The U.S. Department of Defense through the Defense Advanced Research Projects Agency DARPA has officially announced a groundbreaking initiative aimed at developing a hypersonic bomber prototype. This ambitious project, spearheaded by DARPA's Aerospace Projects Office APO, represents a pivotal advancement in military aviation technology, building upon the advancements made in the Next Generation Air Dominance (NGAD) program. The initiative is set to target a deployment timeline for 2025 which could revolutionize both military and civilian aviation. Technological advancements. The Hypersonic Bomber Initiative is expected to harness the innovative turbine-based combined cycle propulsion system showcased in Lockheed Martin's State Route 72 concept. This technology is a significant leap forward, allowing the aircraft to operate efficiently at speeds exceeding Mach 5 times the speed of sound. This capability not only enhances military operational effectiveness but also opens pathways for the development of ultra-fast commercial air travel. As hypersonic technology continues to evolve, it holds the promise of drastically reducing flight times for civilian passengers. By 2025, it is projected that travelers could experience a 60-minute flight from New York to London or a 2-hour journey from Beijing to New York. Companies like Venus Aerospace Hypersonix and Lockheed Martin are at the forefront of this technological race, each working to overcome the challenges posed by extreme speeds and temperatures. Global developments in 2024. The year 2024 was marked by significant advancements in hypersonic technology on a global scale. Noteworthy achievements included: 1. China's hypersonic aircraft prototype. China successfully tested a hypersonic aircraft prototype that reached speeds of Mach 6.56, demonstrating the feasibility of civilian hypersonic travel and underscoring the competitive landscape in this domain. 2. U.S. military advancements. The U.S. military conducted successful tests of its Long-Range Hypersonic Weapon (LRHW), achieving Mach 5 speeds. This capability underscores the strategic importance of rapid strike capabilities in modern warfare. 3. India and Russia's progress. Both countries demonstrated significant strides in hypersonic missile testing, with India's Defense Research and Development Organization (DRDO) and Russia's successful Avangard missile launches highlighting the growing global competition in hypersonic technology. Looking ahead to 2025. As the Hypersonic Bomber Initiative moves forward, several key developments are anticipated in 2025. Venus Aerospace's Stargazer jet. A major test flight is planned for the Stargazer jet, which aims to achieve Mach 6 speeds, potentially setting new standards for transcontinental travel. China's commercial hypersonic airliner. China plans to unveil a prototype of a commercial hypersonic airliner capable of Mach 5 speeds, indicating their commitment to establishing a fleet of hypersonic aircraft by 2035. Public-private partnerships in the U.S. The U.S. Air Force is promoting collaborations with private sector companies to expedite the development of hypersonic commercial aircraft, bridging military advancements with civilian applications. Hypersonic spaceplane. The Australian company Hypersonix is expected to complete its first test launch of a hypersonic spaceplane, further expanding the horizons of air travel technology. Challenges ahead. Despite the excitement surrounding hypersonic technology, several challenges persist. Regulatory frameworks must be established to address safety, environmental concerns, and noise pollution associated with hypersonic flights. As the sector attracts significant investment, stakeholders must navigate the high-risk, high-reward landscape inherent in hypersonic ventures. Conclusion. The Hypersonic Bomber Initiative is not merely a military advancement, it signifies a paradigm shift in both defense capabilities and the future of air travel. With ambitious goals set for 2025, the interplay of technological innovation, commercial interest, and regulatory challenges will shape the next frontier of aviation. The developments in hypersonic technology promise to connect the world in unprecedented ways, transforming how we think about distance and travel while also redefining the strategic landscape of global security. In summary, the implications of hypersonic technology are far-reaching, with the potential to revolutionize both military operations and civilian air travel, paving the way for a new era in aviation. The coming years will be critical in determining how swiftly and effectively these advancements can be integrated into operational frameworks, both in the military and commercial sectors. The Hypersonic Bomber Initiative, announced by DARPA's Aerospace Projects Office (APO), aims to develop a large hypersonic bomber prototype for deployment by 2025. This initiative follows the Next Generation Air Dominance (NGAD) program and represents a substantial advancement in military aviation capabilities. Lockheed Martin's State Route 72 concept, which utilizes a turbine-based combined cycle propulsion system, exemplifies the expected technological advancements in hypersonic flight. Counterintuitive information arises when considering the implications of hypersonic technology beyond military applications. While it is primarily viewed as a military enhancement, there are transformative possibilities for civilian aviation as well. Hypersonic travel could drastically reduce flight times, potentially allowing a flight from New York to London in 60 minutes or a 2-hour journey from Beijing to New York. This suggests a significant leap in global connectivity and travel convenience that could reshape international travel norms. As of 2024, hypersonic technology has seen remarkable progress worldwide, with China testing a hypersonic aircraft prototype that achieved speeds of Mach 6.56, thus validating the potential for civilian hypersonic travel. The U.S. military demonstrated its Long-Range Hypersonic Weapon (LRHW) at Mach 5, showcasing rapid strike capabilities. The advancements made by India and Russia in hypersonic missile tests highlight a competitive landscape that extends beyond the US and China, indicating a broader global interest in hypersonic technologies. Looking ahead to 2025, several developments are anticipated. Venus Aerospace plans a major test flight of its Stargazer jet aimed at Mach 6 speeds, while China aspires to introduce a commercial hypersonic airliner capable of Mach 5. The U.S. Air Force is fostering public-private partnerships for developing hypersonic commercial aircraft, and Hypersonics expects to complete its first test launch of a hypersonic spaceplane. However, the rapid advancement of hypersonic technology is accompanied by significant challenges. Regulatory frameworks must evolve to address safety, environmental, and noise pollution concerns, which could obstruct the path to commercialization. Investors are keenly aware of the high-risk, high-reward nature of hypersonic ventures, as successful commercialization could yield substantial returns, yet the technological and regulatory hurdles remain significant. The interplay between military advancements and commercial interests paints a complex picture of hypersonic technology's future. While there is enthusiasm for its potential to revolutionize air travel, the challenges of establishing regulatory frameworks and ensuring safety and environmental sustainability are critical to its successful integration into both military and civilian sectors. In summary, the Hypersonic Bomber Initiative is not merely a military endeavor. It stands at the intersection of significant advancements in aviation technology with far-reaching implications for both defense and civilian travel. The juxtaposition of military technological competition with the potential for transformative civilian applications reveals a counterintuitive narrative where the future of hypersonic technology could redefine global air travel norms while simultaneously enhancing military capabilities. The announcement of the Hypersonic Bomber Initiative by DARPA's Aerospace Projects Office (APO) has garnered significant attention, yet several crucial aspects may be overlooked which have profound implications for both military strategy and civilian aviation. Here are the key points that merit deeper consideration. 1. DARPA's low-profile approach and secrecy. The existence of DARPA's APO, which is not prominently featured on the agency's website, reflects a strategic decision to operate under a veil of secrecy. This approach is significant because it highlights the sensitive nature of hypersonic technology and its military applications. The lack of visibility can serve multiple purposes. Security. Keeping details under wraps prevents potential adversaries from gaining insights into technological advancements which could mitigate the U.S. military's operational advantages. Innovation culture. A low-profile existence allows for a more agile and less bureaucratic approach to research and development, fostering innovation without the constraints of public scrutiny or political pressures. 2. Rapid global advancements in hypersonic technology. While the U.S. is making strides, the advancements in hypersonic technology by other nations, particularly China, India, and Russia, are crucial yet often understated. China's achievement of Mach 6.56 with its hypersonic aircraft prototype is a watershed moment. This development has several implications. Strategic balance. The ability of other nations to reach hypersonic speeds challenges U.S. military dominance and could lead to a shift in global power dynamics. It underscores the need for the U.S. to not only accelerate its own technological developments but also to reassess its strategic military posture. Civilian applications. The feasibility of civilian hypersonic travel demonstrated by these advancements suggests that the commercial sector may soon follow, potentially creating new markets and altering international travel dynamics. 3. Public-private partnerships in hypersonic development. The U.S. Air Force's emphasis on public-private partnerships to facilitate hypersonic aircraft development is a significant trend that could reshape the aerospace landscape. This model has several advantages. Resource pooling. Collaboration with private firms allows for sharing of expertise, funding, and technological resources which can accelerate innovation. Market incentives. By involving private companies, the Air Force can leverage market dynamics to drive competition and efficiency in hypersonic development, which is crucial given the high costs and risks associated with such technologies. 4. Regulatory and environmental challenges. The anticipated regulatory frameworks for hypersonic flight are a critical aspect that is often overlooked. The implications of this are profound. Safety and noise pollution. As hypersonic travel becomes more viable, regulators will need to address issues related to safety standards and environmental impacts, including noise pollution from aircraft traveling at supersonic speeds. This could lead to significant delays in the commercialization of hypersonic travel. Global cooperation. Establishing international regulations for hypersonic flights is essential to ensure safety in increasingly crowded airspaces. The lack of a coherent regulatory framework could hinder the development and deployment of hypersonic technologies. 5. Investment landscape and market dynamics. The hypersonic sector presents a high-risk, high-reward scenario for investors, which is crucial for the sustainability of innovations in this field. Key considerations include long-term commitment. Investors must recognize that while the potential returns are massive, the timeline for viable hypersonic technology could extend beyond initial expectations. Understanding the long-term nature of aerospace investments is vital. Diverse opportunities. The rapid advancements in hypersonic technology create a variety of investment opportunities across sectors, from defense contractors to commercial air travel startups. Investors should diversify their portfolios to mitigate risks associated with individual projects. 6. Impacts on global military strategies. The Hypersonic Bomber Initiative is not merely about developing new aircraft. It represents a fundamental shift in military strategy. Deterrence and response capabilities. The ability to deploy hypersonic weapons can serve as a deterrent against adversaries, fundamentally altering the calculus of military engagement. This could lead to a new arms race focused on speed and precision. Integration with existing systems. The integration of hypersonic capabilities into existing military frameworks will require significant changes in tactics, training, and logistics, which are often underestimated in discussions about new technology. 7. Civilian hypersonic travel and its repercussions. While the focus is often on military applications, the potential for civilian hypersonic travel can have broader societal implications. Economic impact: drastically reduced travel times could reshape global business operations, increase international trade, and alter tourism dynamics. This could lead to economic growth in regions previously considered remote or hard to reach. Societal changes: the advent of hypersonic travel could lead to changes in work-life balance as commuting becomes feasible over long distances, potentially reshaping urban planning and housing markets. Conclusion: the hypersonic bomber initiative is a complex endeavor with far-reaching implications beyond military applications. The interplay of technological advancements, geopolitical dynamics, regulatory challenges, and investment opportunities paints a multifaceted picture of the future of hypersonic technology. Recognizing these overlooked aspects is essential for stakeholders across military, commercial, and regulatory spheres to navigate the emerging landscape effectively. The Hypersonic Bomber Initiative, driven by DARPA's Aerospace Projects Office APO, signals a transformative leap in military and civilian aviation capabilities. Here are 4 valuable points for in-depth analysis and discussion. 1. Technological advancements and strategic military implications. The development of the hypersonic bomber prototype marks a significant shift in military aviation technology. Lockheed Martin's State Route 72 concept, which utilizes a turbine-based combined cycle propulsion system, exemplifies the cutting-edge innovations expected from this initiative. This capability allows for rapid strike missions that could fundamentally alter the strategic landscape of military operations. The ability to deploy weapons at speeds exceeding Mach 5 can provide forces with unprecedented reaction times, enabling them to respond to threats more effectively than ever before. Furthermore, this initiative comes at a time when global powers are heavily investing in hypersonic capabilities, with China and Russia demonstrating significant advancements in hypersonic missile technology. The competition in hypersonic weapons could lead to an arms race that reshapes international security dynamics. 2. Civilian aviation revolution. Beyond military applications, hypersonic technology holds the potential to revolutionize civilian air travel. Companies like Venus Aerospace and Hypersonix are racing to develop hypersonic passenger aircraft that could reduce travel times significantly, such as a 60-minute flight from New York to London. Such innovations promise to enhance global connectivity and reshape commercial aviation by making long-distance travel not only faster but potentially more efficient. The implications for tourism, business travel, and global commerce are profound, opening up new markets and opportunities for industries linked to air travel. However, the transition to civilian hypersonic flights requires addressing technical challenges, including safety, environmental impacts, and regulatory frameworks to govern the new airspace requirements. 3. Investment landscape and economic implications. The hypersonic technology sector is characterized by its high-risk, high-reward nature, attracting considerable interest from investors. As companies pursue advancements in hypersonic technologies, the potential for lucrative returns on investment is significant, particularly if commercial hypersonic airliners become viable. Investors are keenly watching developments in propulsion systems, materials science, and engineering solutions that are critical to overcoming the barriers of hypersonic flight. With multiple countries and companies vying for leadership in this emerging market, there is a clear opportunity for substantial economic growth, but it also comes with inherent risks tied to technological feasibility and regulatory acceptance. The balance between innovation and regulation will be crucial in determining the pace of investment and adoption of hypersonic technologies. 4. Regulatory challenges and environmental considerations. As hypersonic technology evolves, it raises pressing regulatory and environmental concerns that must be addressed. Issues such as noise pollution, safety standards, and environmental impacts from increased air travel must be at the forefront of discussions among policymakers and industry leaders. The development of comprehensive regulatory frameworks will be essential to ensure that hypersonic flight does not adversely affect communities and ecosystems. Moreover, as the aviation industry faces growing pressure to reduce its carbon footprint, the sustainability of hypersonic technologies must be evaluated to align with global environmental goals. The interplay between technological advancements, regulatory measures, and environmental considerations will shape the future landscape of both military and civilian hypersonic aviation. In conclusion, the Hypersonic Bomber Initiative is not just a military endeavor. It represents a broader trend that intertwines technological advancements with economic, regulatory, and environmental factors. The discourse surrounding hypersonic technology will likely evolve as stakeholders navigate the complexities of deploying these capabilities while addressing the challenges they present. 1. The Manhattan Project 1942–1946. This was a secret project led by the United States during World War II to develop the first nuclear weapons. Spearheaded by physicist J. Robert Oppenheimer and involving prominent scientists like Enrico Fermi and Richard Feynman, the Manhattan Project was a massive undertaking that combined military and scientific efforts to achieve a significant technological breakthrough. The project culminated in the development and successful detonation of the first atomic bomb known as the Trinity test in July 1945. The project not only changed the dynamics of warfare but also ushered in the nuclear age, leading to profound implications for global security, international relations, and military strategy. 2. The Space Race 1957–1975. The space race was a competition between the United States and the Soviet Union during the Cold War to achieve significant milestones in space exploration. It began with the Soviet Union's launch of Sputnik 1 in 1957, the first artificial satellite to orbit the Earth, which shocked the United States and marked the beginning of a new era in technological competition. The U.S. responded with increased funding for its own space programs, leading to the creation of NASA. Key achievements included the first human in space, Yuri Gagarin, in 1961, and the Apollo 11 mission, which landed humans on the Moon in 1969. The space race not only advanced human understanding of space but also showcased the technological prowess of the competing nations, influencing military strategies and international diplomacy. 3. The development of stealth technology 1970s–present. Stealth technology represents a significant advancement in military aviation, aimed at minimizing the detection of aircraft by radar and other sensors. This technology was first prominently developed in the 1970s with projects like the U.S. Air Force's F-117 Nighthawk and later the B-2 Spirit bomber. The successful application of stealth technology has transformed air combat and strategic bombing capabilities, allowing for precision strikes with reduced vulnerability to enemy defenses. The ongoing development and refinement of stealth capabilities have influenced military strategies worldwide, prompting other nations to invest in similar technologies, thus reshaping modern warfare dynamics. These cases exemplify significant technological initiatives with profound implications for military capabilities, international relations, and the evolution of warfare, similar to the current Hypersonic Bomber Initiative. Future outlook: predictions for the Hypersonic Bomber Initiative and hypersonic technology by 2025. The announcement of the Hypersonic Bomber Initiative by DARPA's Aerospace Projects Office (APO) marks a pivotal moment in military aviation, with ambitious plans for deployment by 2025. This initiative is not only set to redefine military capabilities but also to catalyze significant advancements in civilian aviation. Here's a detailed prediction for the developments expected by 2025 and beyond, focusing on both military and civilian applications of hypersonic technology. 1. Military applications and strategic impact. The Hypersonic Bomber Initiative represents a leap in military aviation technology, with Lockheed Martin's State Route 72 as a prime example of innovations aimed at achieving speeds exceeding Mach 5. By 2025 we expect operational readiness. The United States will likely have a hypersonic bomber prototype ready for testing, with initial operational capabilities being demonstrated. This would enable rapid response capabilities to emerging global threats, enhancing strategic deterrence. Global arms race. As the U.S. progresses with its hypersonic bomber, other nations, including China, Russia, and India, are expected to accelerate their own hypersonic weapon programs. This could lead to a significant shift in military balance, with hypersonic technology becoming a central focus of defense strategies worldwide. Enhanced strike capabilities. The introduction of hypersonic bombers will provide military forces with the ability to strike targets at unprecedented speeds, reducing adversaries' response times and complicating their defense systems. This capability will likely shift military doctrines towards preemptive strategies. 2. Civilian aviation transformation. Hypersonic technology is poised to revolutionize civilian air travel, offering unprecedented speed and efficiency. By 2025, we predict commercial hypersonic flights. Companies like Venus Aerospace and Hypersonix are expected to conduct successful test flights of hypersonic jets such as Venus's Stargazer, aiming for operational routes that could connect major cities in significantly reduced times, e.g. New York to London in 60 minutes. Regulatory frameworks established. As hypersonic flights become a reality, regulatory bodies will likely develop new airspace regulations addressing safety, noise pollution, and environmental concerns. This could lead to a structured approach for integrating hypersonic travel into existing aviation frameworks. Public acceptance and demand. With successful demonstrations of hypersonic flight, public interest and demand for ultra-fast travel options will likely increase. This could catalyze investments and further developments in the sector, positioning hypersonic travel as a viable option for business and leisure travelers. 3. Technological advancements and challenges. The path to achieving hypersonic capabilities is laden with technical challenges that must be addressed. Material science innovations. Significant advancements in materials capable of withstanding extreme heat and pressure will be critical. By 2025, we may see breakthroughs in heat-resistant materials and coatings that can facilitate safer and more efficient hypersonic flight. Propulsion systems development. The development of turbine-based combined cycle engines, as seen in the State Route 72 concept, will be a focus area. Successful implementation could lead to more efficient fuel usage and expanded operational ranges for hypersonic aircraft. Environmental considerations. The rapid advancement of hypersonic technology will necessitate thorough assessments of environmental impacts. By 2025, we could witness the establishment of frameworks aimed at mitigating the ecological footprint of hypersonic travel, balancing technological progress with sustainability. 4. Investment and economic implications. The burgeoning hypersonic sector presents both opportunities and risks for investors. High-risk, high-reward investments. The hypersonic technology market is expected to draw significant investment as companies seek to capitalize on the potential of rapid air travel. However, investors will need to navigate the high-risk nature of the sector, as technological feasibility and regulatory hurdles could impact timelines. Partnerships and collaborations. Public-private partnerships will likely play a crucial role in advancing hypersonic initiatives. By 2025, we may see increased collaboration between government entities and private aerospace companies, fostering innovation and accelerating development timelines. 5. Global collaboration and competitiveness. The hypersonic race is not limited to a single nation. International research collaboration. As countries recognize the strategic importance of hypersonic technology, we may see a rise in collaborative research initiatives aimed at addressing common challenges such as safety and environmental impacts. Competitive landscape. The competitive nature of hypersonic technology development could lead to a new era of innovation across the aerospace industry. Countries like China and Russia are expected to continue pushing their capabilities, making the hypersonic sector a critical focus in international relations and defense policies. Conclusion. The Hypersonic Bomber Initiative and the broader push for hypersonic technology signify a transformative era in both military and civilian aviation. By 2025, we can anticipate significant advancements, operational prototypes, and regulatory frameworks that will shape the future of air travel. While challenges remain, the potential for a revolutionary shift in how we think about speed, connectivity, and military strategy is undeniably on the horizon, making the next few years crucial for the development and implementation of hypersonic technology.